Welcome back. Example 6. Sketch the curve r equals cosine 2 theta. As in the previous case, we will allow these various angles for theta. Notice pi over 6, pi over 4, pi over 3, they fall in the first quadrant. 0, pi over 2, they are on the x and y axis respectively. 2 pi by 3, 3 pi by 4, 5 pi by 6. These fall in the second quadrant. Pi on the x-axis. 7 pi by 6, 5 pi by 4, 4 pi by 3. These fall on the third quadrant. 3 pi by 2 on the y-axis. 5 pi by 3, 7 pi by 4 and 11 pi by 6. These fall on the fourth quadrant. Use these angles for theta and calculate r using the formula r equals cosine 2 theta. Substituting theta, you get various values of r. Once you have these values of r, you now have points in polar coordinates r, theta. R is the distance from O, theta is the angle measured in radians counterclockwise from the polar axis. So you get these points in polar coordinates. Now we start plotting them. You see how beautiful this picture is. So here are the three first quadrant angles, second quadrant angles, third quadrant, fourth quadrant, and then angles on the x and y axis. All right. So using the distance, so that is here, distance 1/2. Pi over 4 gives you distance 0. So you see, pi over 6 gives you distance 1/2. Pi over 4 gives you distance 0. So you're back here. Then you climb up until you hit distance 1, 1/2, 0, 1/2, 1, 1/2, 0, so on. Okay. So some of these, you notice, distances are negatives. So what's the situation there? So here is at pi by 3, angle is -1/2. So at pi by 3, what happened? So you collapsed. At pi by 4, and then you didn't go up, you went down, negative distance. So it's important, although this looks like you start here, go here, climb up here. No, it's actually going down here. And then, so those also result in negative distances, okay? What I mean is these are the second quadrant angles. Notice you have negative here, okay? So 2 pi by 3, you are not placed here, but here, okay? So this is the trajectory. You start here, roll below, roll, there. All right. So to make sure you have the correct values, check every detail here. Angle 5 pi by 3. Angle 5 pi by 3, I want a radius -1/2. 5 pi by 3 is over here. So I am not, this is not the point -1/2. That's the point -1/2. So what does this point correspond to? This point corresponds to 2 pi by 3. Look at 2 pi by 3, radius -1/2, and so on. Okay. So keep track of where you are. You will get a beautiful picture. Now, few notes about symmetry. If the polar equation is unchanged when theta is replaced by negative theta, then the curve will be symmetric about the polar axis. So that's your polar axis. If theta is replaced by negative theta in your equation and you get the same equation, then you are going to be symmetric as in here. If the equation is unchanged when r is replaced by -r, or when theta is replaced by theta plus pi, then the curve is symmetric about the pole. So if something, not this one, there are no examples here so far, but you see in your equation, if r is replaced by negative r or theta is replaced by theta plus pi, what does that mean? By rotation of 180 degrees, you would get the same picture. All right. If the equation is unchanged when theta is replaced by theta pi minus theta, then the curve is symmetric about the vertical line. All right. Tangents. Now, this is an important small topic before we go to problems. Recall, x is r cosine theta. Therefore, dx d theta will be by product rule dr d theta times cosine theta minus r, derivative of cosine is sine theta. You see, y is r sine theta. Again, dy d theta by product rule is dr d theta sine theta plus r, derivative of sine is cosine theta. So dy by dx is dy by d theta on the top and dx by d theta on the bottom. All right. So you replace the numerator dy d theta by its expression and dx d theta by its expression. Okay. When r is 0, what happens? These two go away and you are left with only sine theta over cosine theta, that is tan theta. So when r is 0 and dr d theta not 0, so that's when you get to cancel. When we obtain horizontal tangents, when do you obtain horizontal tangents? When the numerator is 0, that is dy d theta is not 0, provided denominator is non-zero. We get vertical tangents when dx d theta, that is the denominator, is 0, provided the numerator is not 0. Okay, this is a short summary on tangents. Next video will cover problems from web work. Until then, bye.